Hello, everyone, and welcome to the Hatchery 101 webinar series by Hatchery International. My name is Ben Normand, and today I will be your host and moderator for today's discussions on waste management. Now, before we get into today's discussion, I'm pleased to announce that Hatchery International, Hatchery 101 will be back in 2024. We have an exciting suite of topics in store for you. On February 14th, we will celebrate our love of fish farming by exploring the genetics, genomics, and broodstock management. On May 15th, we'll explore the exciting frontier of digitization and AI in hatchery operations. On August 14th, we will discuss pathogen management and what that can look like in a changing world. As well, on November 13th, we're actually going to use a audience pick for our topic. So before you should see a poll popping up soon where you can contribute your opinion on which topic we should explore on November 13th. And the options are, of course, extreme weather challenges, workforce development, feed management, feed alternatives, carbon footprint management, and we have an option for you to suggest another topic that you might like. If you could kindly take a moment to fill out that poll, it will help us pick that topic, and we would be very grateful, and we look forward to discussing what you choose. Now, on to today's topic. In order to protect the natural resources that drive hatchery production, hatcheries must implement clear and conscious waste management protocols. Today, our panel of experts will share best practices and sustainability-centered strategies to help you ensure the future health of your operating environment. Before we begin, I would like to acknowledge once again the sponsor of this webinar series, Oxygard International, without which this webinar series would not be possible. Now, we'll introduce our panelists. We have Laura Bailey. She's a project engineer with McMillen Engineering. We have Trevor Gent, who's a director of sales and marketing at Alumichem. And we have Aaron Switzer, who's the area hatchery manager at the Michigan Department of Natural Resources. Welcome all. Now, just so you folks are aware, this webinar is being recorded, and that recording will be available to you via email within 48 hours. For our viewers as well, I'd like to remind you that this webinar will be made up of two parts. The first part of this webinar will consist of a panel discussion, and then in the last 15 minutes, we will be answering audience questions. Now, if you do have a question that you'd like to ask the panelists, please use the Q&A function at the bottom of your screen as opposed to putting the question in the chat function. Now, for all ready, we can get started. So to start off, let's start with the basics here. What is the standard benchmark for hatchery operators in terms of which wastes they should be measuring, controlling, or avoiding? Aaron, if you'd like to start us with this one, please.
Awesome. Yeah, I think right away when I think of waste management at a facility and what we need to control, measure, or avoid, I think of metabolic waste to start with, and phosphorus specifically in Michigan has been something that we've struggled with, and we're getting better at managing because phosphorus, if we're dumping phosphorus out, we are polluting the environment, and of course we're under National Pollution Discharge Elimination System regulations, and so TSS, total suspended solids, and phosphorus are a couple of the big ones that we're always measuring and consistently measuring. So those are definitely two that we want to measure. As far as other wastes, besides that, there's just other waste besides metabolic waste. So we think about pathogens and things that could be coming out of your facility. At least I think about that. Or the drugs or chemicals we use to treat if we have some sort of outbreak, or if we're treating prophylactically. And those can all be neutralized typically with other chemicals. So pH, of course, is another important measurable unit. And then I guess finally, when I think about waste, I think about invasives. So is there anything that we're doing that could be invasive to the environment around us? And monitoring that, making sure that you aren't introducing anything new into the environment where your system is. So I'll let another panelist go on from there. I covered a lot of ground, I think.
Yeah, I guess I'll just, I feel like we're probably going to talk about discharge limits a lot in this webinar today, because I think that's so dependent on what you are controlling and measuring and monitoring is basically what you're allowed to put out as waste. And I think, it's going to be different by every state. I used to live in Maryland, and when I worked at the Freshwater Institute, we were in West Virginia, which is a Chesapeake watershed, which has really tight discharge limit. Like Aaron said, phosphorus and nitrogen is something else that we're looking at, total TSS. So it's really, dependent on the area of, what you're watching for. I'd also say that, I think we have a good panel of people who work in commercial hatcheries and conservation hatcheries, and those two are going to be pretty different. Conservation hatcheries have a lot lower densities, and so they're going to have lower waste, maybe more volume, a lot more water, but lower total suspended solids, whereas commercial hatcheries are a lot higher densities and a lot higher waste. So.
That's great. Thank you. Let's take that a step further here. And what's sort of the gold standard in modern hatchery operation for waste management? And just as an extension of that question, then are we seeing zero waste or net zero facilities? Trevor, if you'd like to take the lead on this.
Yeah, I was going to start talking on the first question and then realized I'm just stealing my own thunder. So I appreciate it. It's a challenge, and I appreciate where everybody was going with the TSS and the phosphorus, and I like the way that you phrased that, Aaron. Metabolic waste. That sounds so much better than the way I say it. My daughter loves to say I clean fish poop. It's just it's an easier way. But and by the way, she's 22, not 12. But either way, so the gold standard, I think you have to look at waste in two aspects. There's the liquid side, and then the solid side that you're putting back on the liquid side. I completely agree with Aaron and Laura. It's TSS, it's phosphorus. You start to think about your COD, your BOD, and nitrogen can come into that concept. I think the gold standard in that process is really making sure that you're separating your solids and liquids as best you can, whether you're using lamella separator, band, or, belt filter, drum thickener. There's lots of different technologies that can be deployed. Understanding the water treatment chemistry, I think, is also really important. I run into this quite a bit with clients where they talk about, no, we add polymer. And as a water treatment guy, I've been in water treatment since 1998. When somebody says no, we add polymer, I just kind of cringe, because there's somewhere between 50 and 5,000 different polymers and different mechanisms and process. So regardless, gold standard is understanding the water treatment chemistry. Then the next step would be to polish that water, and to go one step further and actually treat it with either ozonation or UV to ensure that we are killing off any microbiological activity through that process. And again, if you're going to use ozone, you make sure you use UV, but to make sure that we are neutralizing that microbiological carryover that might come from the water side or from the fish. If you go to the solid side, that's an even more complicated question, because it really depends on what options do I have for getting rid of my waste. So that sort of leads to the zero waste, net zero facilities. I think that's everybody's dream. Could we come up with this wonderful, perfect circular economy where the water gets reused and the waste gets used by either put into compost, put into fertilizer, put into, I think the most recent one I saw is there's a group looking at using worms. I love them all. I think they're all fantastic, and I do think it is definitely the direction that we need to look at as professionals in the industry. It always is going to tie back though to, I'm a fish farmer, I'm a hatchery producer. Do you know what I mean? Do I really want to take on other business models, other concepts, other processes? And so the gold standard is ultimately making sure you're meeting your discharge limit parameters, and trying to go a little bit further in certain cases. there's always the group that's going to treat themselves as the basic process of, I'm going to hit the discharge limits and only the discharge limits. But one of the questions I always like to ask our clients is, well, that's great, but what do you as a corporate sustainability, what are your corporate sustainability goals? What are your corporate ESG guidelines, and where do you want to be seen in the industry? You know, is it just the guy that hits the discharge limits, or is it the guy that goes beyond? Right. And so I think those are good questions that we have to ask ourselves through this process, but it's always going to be money driven through that. You know, we have to be realistic in that space. I think so. That would be my take on gold standards, making sure that you got the highest and best return of water. And then, can you deploy your waste, the solid stream? You know, can we go to biogas? Can we use it as a soil amendment? How can we recover some of those phosphoruses and nitrogens and high quality products that are in there without leading towards more eutrophication in our existing systems, right?
Trevor, do you see then, and it sounds like this might be the case, do you see what is sort of our definition of what constitutes waste expanding in hatcheries over time?
Very much so. I think the other aspect, and as I know I'm leading sort of into the next stage here, as we go more land-based, in that concept, we're getting treated more and more as, you know, an industrial facility versus a farm. Which means more and more gets treated as waste, and you can start to evolve that into, well, what are you throwing away, right? What plastics are you throwing away? Styrofoams. How are you dealing with other waste? And so I do think that you know, sort of this overall mass balance is going to start to kick in on facilities in terms of that process, and you know, the thought process of, well, just because it's not a waste today doesn't mean it's not a waste tomorrow, needs to be part of the mindset as well.
Aaron, what do you think drives this expansion through time?
Can I just add a couple of things to
Absolutely.
No, I disagree. You can't.
Yeah.
No.
No,
He summed it up perfectly.
Trevor sparked a couple thoughts in my mind as he was going through gold standard, net zero. A couple of things with that is operator awareness, and understanding how your system works is extremely key to, you know, hitting a gold standard or getting to that point where you understand what's going on at your facility. And this, I feel like a lot of this is, you know, stuff that's emerging right now and really becoming more evident to operators. So operator awareness, and to just one thing on top of that is, you know, for operators out there, if you can build a mass balance to know what's coming into your hatchery, what you are inputting with food, etc., and understand, that gives you the next layer, in my opinion, of understanding what's going on at your facility and helps you manage your discharge much better.
It's an interesting point, Aaron. Two things came to mind when you said that. The first is, ignorance is not bliss when it comes to waste management. And the second is, I was recently at a conference in Iceland, and one of the fish farmer owners was talking about, and the numbers won't be right, but the relevance is there. He said, you know, when we first started fish farming, we monitored 10 parameters and measured 5. And now we monitor 2,500 and measure 150. You know, and so you start to realize that, you know, you brought up mass balance. We talk about phosphorus and nitrogen and TSS. Well, what about the calcium that we're adding? What about the magnesium, the zinc, the metals and the vitamins that we're adding to this process? And you also talked about the vaccines and other things that are metabolizing and coming out. I mean, what is coming out in that water or in that waste that we need to be cognizant of?
And I think just going back to this idea of a gold standard or the zero waste is, I think there's a lot of room between where we are now and this idea of zero waste, that, you know, we we can make a lot of progress in that zone without actually being zero waste.
Well, and let's be honest, what is zero waste? Everybody
Yeah.
that talks about there, I struggle with that context in as a, the engineering background in me that says nothing can be created or destroyed.
No, I feel the same way of that zero waste is it's not really zero waste because you're just doing something different with it.
If
right?
something's leaving your plant, guess what?
Yes. And I do think there's a lot of interesting facilities that are like reutilizing that waste in a different way, but I'm hesitant to say zero waste.
Yeah, no, I'm kind of on the same page.
So Ben, you asked me a question, and I went a different direction, so I apologize for that.
Absolutely, no worries.
What the major drivers were for expansion?
Yeah, expansion of our definition of waste, but then also I suppose this sort of expansion on like what Trevor touched on, the expansion number of parameters you're even looking at, et cetera. Like what's propelling this shift?
So at from my standpoint, at I don't know, 50,000 or 30,000 foot view, it's public perception and awareness, and that is related to global climate change. From my perspective, way high. That's what I think is driving us in that direction. But I do see, as outside of just metabolic waste, being cognizant of what else we are putting in our facilities, and going back to chemical treatments and drugs that we may use to treat fish. What kind of pathogens could we releasing in Michigan? We're big on the state of Michigan is big on sport fish restoration, and we're high density. Okay. And fish get sick, and we don't want to release pathogens into the environment. So we're very conscious about what we're doing, and we're getting better about it. And sometimes it's people from outside that ask us questions and say, well, what are you doing about this? That make us think about, wait, you know what? Maybe we should be treating that a different way in order to be more environmentally friendly.
I would also kind of add on to that. And I think a lot of, at least with conservation hatcheries, there's concern about the natural rivers, especially where we're stocking the fish. And so much of these hatcheries are, on the river where they're stocking out the fish. And so making sure that those rivers have a water quality that can, maintain, a natural stock is really important. So I think that's a big driver in terms of, not discharging pathogens, not discharging nutrients. And then kind of flipping to the commercial side, I would also say two kind of key drivers is the size of the facilities. These facilities are getting a lot bigger. And so it's a lot more waste that is going out into the environment, or that these facilities have to deal with. And then also with commercial is cost, right? When you're just dumping waste, that's instead of reutilizing it or reusing it in a way that can either, reduce operating costs or kind of reduce the cost to get rid of it. I think those are two other kind of key drivers that are kind of important to consider.
Just touching on what you mentioned here, Laura, in the commercial context, and Trevor, you touched on something similar earlier where you're discussing, some groups operating in the aquaculture sphere that might, very happy to just sit at the minimum threshold for mitigation, and then there's some that wish to go beyond. And does that all, in your experience, tie back to what Aaron said, back to public perception? So you have a corporation that maintains hatcheries, they're going way above and beyond the limits. Is it usually that, despite increased costs, is it usually just to sort of boost public perception, or have you noticed other factors driving that?
I think from my perspective, if I want to be the pessimist, I'd say, yeah, it's just the public perception aspect. But I think looking at what Aaron said with regards to, climate change and the way the globe is, I do believe that most of these companies that set the bar higher are doing it not for the public perception concept. I think that's a win. Don't get me wrong. I do think that that's a factor when they consider it. But I like to believe that they're doing it for the right reasons, and I do believe they are. They're doing it for for the organization, for the fact that let's face it, most of these organizations are big. A lot of them started as family-based companies. They were, mom and pop fishermen that started with one boat, and now somehow they're global entities. So they still kind of have this family atmosphere. And so I do believe they're looking at it for the right reasons. But does public perception take a light in that? Of course it does. I mean, that's for sure a component, but that's why we do a lot of things. Is how is this going to be perceived by the public? How is this going to be perceived by our shareholders? How is this going to be perceived by our competitors or our colleagues in the industry? Those are all factors that come into play, but I like to put the hat on that says, no, they're doing it for the right reasons.
Yeah, I would second what Trevor says. I like to think that most of these companies are, want to build a sustainable brand. But I do think public acceptance is pretty big, at least, like Trevor said, the global idea, but also like locally is if they see these facilities that aren't handling their waste or just discharging right into a local body of water, we've seen some public pushback from that. And I think, that's
well, and let's face it, we not just the fish industry, but a lot of industries have had a pretty bad reputation of just pumping waste into the ocean because it's deep and wide and the current carries it away, right? And it's 70% of the earth or whatever the heck the number is, right? And it's good, it's fine, we don't care about it. I think that needs to evolve, and I think that has evolved as a global industry, as well as the overall perception of waste in general.
Dilution is not always the solution.
The solution to pollution is dilution. No, well, and I mean that's it's funny you bring that up. I brought that Canadian mentality to Europe, and they looked at me and said, no, that doesn't work, buddy. But it's even back in Canada, my hometown, they're starting to separate the streams. You can't just add them together. It's like no, this one has to meet the guidelines, and so does this one. You don't get to merge them.
Well, it's great to see that sort of that genuine concern driving that forward for sure. And I'd agree with you there. So turning our attention to land-based systems and we're seeing a big push and a lot of effort and a lot of money being spent in building these much larger facilities and in different life stages as well, all over the world. And so are there specific waste concerns that operators in these contexts should be thinking about? Laura, would you like to take lead on this?
Yeah, so when I think of land-based, I'm obviously going to go to RAS because that's kind of where my background is. But I think RAS has the advantage of reducing the total volume of waste that's leaving the facility, right? If you're only putting 5% of water in, only 5% of that total flow is going to come out compared to like flow through systems. But the problem with that is that 5% flow is going to have a much higher solids content. And, you have to do some further treatment before you can discharge it to the environment. Where some flow through systems, the solution to pollution is dilution, and it's acceptable in some places. With RAS, you really have to do further treatment. But that solids content is pretty high, and for its smaller facilities, like especially like conservation hatcheries, just some additional dewatering can be sufficient, such as like gravity thickening settlers, settling ponds, or drum filters. But when you really get into these bigger systems, 5% of the flow of a large facility is still a lot of flow. And a lot of times further treatment is needed. And ultimately, I'd say how that waste is handled is kind of where you're at. The regulations in Florida are going to be different than they are in Maine. And again, with the large facilities, public perception, I would say is really important. The one thing I think that's important consideration, especially for some of the different life stages, is saltwater versus freshwater. There's a lot more options in terms of what you can do with a waste from freshwater, just in terms of like land application and some of that, whereas saltwater, it's a lot more restrictive. And I haven't worked with saltwater as much, so maybe Trevor could touch more on that, but.
Yeah, it certainly complicates the space. I mean, the interesting part about the fish world is you're dealing in everything from, you know, sort of 6 degrees Celsius. Sorry, it's the Canadian in me. You guys can do the conversion somewhere out there. You know, 6 degrees Celsius to 30 degrees Celsius water, and, you know, 0 ppt salt up to 30 ppt salt and higher. You know, so the solids content becomes an interesting concept of what can we do with this solid that is, you know, really, for lack of a better term, is manure, right? And isn't necessarily always defined as manure. It gets defined in different ways in different regions, but it still has value, even though the chloride content is higher in certain cases. You know, and they've certainly done research and found that it can be used in fertilizers, it can be used in biogas facilities, it can be used as one of the more unique options is to use it in cement factories as an alternative fuel source. You know, because the chloride is actually an advantage to the cement factory. But again, finding a location that can use that alternative fuel source, it also changes. You've got groups that are looking at pyrolysis, groups that are looking at compost. Like I said, you got worms that are being evaluated. And the interesting thing about waste in this concept, especially in the land-based world, the more you recirculate, the more complicated your waste treatment gets too, right? Because the more you're recirculating means the more nitrogen and ammonia you're converting. The more you recirculate, the more concentrated your waste is becoming. You know, the other thing that's really interesting about the fish farming and the RAS facilities is the biomass changes that come into play. And I was smiling as Laura said, you know, the flow through versus the RAS, and you concentrate. I'm like, yeah, well, the beauty of it is, you know, with the flow through, you have the same biomass of fish and you feed it the same amount, but shockingly, whether you're recirculating the water or not, they still excrete the same amount. The food amount is still related to the biomass amount, right? The presence of everything doesn't change. It just becomes more interesting and more complicated. And then, you know, you mentioned it too, Laura, the region to region variation in discharge limit requirements also plays a major role in that process. You know, do I have a biogas facility nearby that can take an 8% dry matter solution happily and then it's gone? It's not my problem. You know, or do I have to dry it to a 90% or higher dry matter so that then I can store it and see what I can do with it? You know, can I take it off? There's a group in Norway that's taking salty dry matter from fish farms and converting it into fertilizer in Vietnam, which is a fantastic solution. But is it the right solution? Are we just deferring it to another country? In a different way, right? I mean, it feels circular and it feels great. I mean, but it's also a little bit of out of sight, out of mind.
Let's shift to land-based opportunities here. We were talking about the sort of expansion of what constitutes waste. Laura, do you see this trend in the industry as maybe another driver that might drive further expansion of that definition of what is even waste?
Yeah, I feel like the thing with land-based is it's such a controlled environment. So I think we have a lot more awareness about what's going into the system and ultimately what's going out. So kind of like Trevor mentioned with that example of monitoring and measuring 10 things versus, you know, 150. I think it's a lot of the same, you know, with land-based or with RAS, is we're not necessarily producing more waste. We're just a lot more aware of what waste is coming out of the system. And I think with RAS, there is a lot, like that waste stream is a lot more controlled. And so I think there's a lot of opportunities to, you know, further treat it or further reutilize it. And I have seen some interesting projects that are, taking what could be considered waste and reutilizing it, either whether, with like cold water systems, is that cold water was chilled, right? And so using energy recovery to chill water coming in by the chilled water leaving is always like an interesting use. Or with marine systems, there's some talk about salt extraction, of reusing the salt in the system. And so I don't think necessarily the definition of waste is expanding, but I think with RAS, there's a lot more opportunity to turn that waste back into the system in some interesting ways. I mean, I guess the other advantage too of, in terms of RAS, of the controlled environment, is, talk about things going in, is we have a lot more control of the feed going, and there's some, interesting stuff of monitoring how much feed, and because that solids waste is a lot of uneaten feed, we can reduce how much uneaten feed is going in, we can reduce how much feed is going out. So I think it doesn't necessarily change it, how we define it, but maybe how we manage it.
I think the only addition I would put on that is I because of the concept, and you made me think of that when you the chiller in and out. I mean, is that waste? That's energy waste, right? It's a heat source. Is what other aspects, and I can't define it other than perhaps that energy waste is the biggest one. But are there ways that we could use the wastewater off of the end of pipe treatment, that we don't want to recirculate it back into the RAS system or the land-based system right now, but is there another place that we could recirculate that back into a process that we could utilize it one step further? Obviously aquaponics comes to mind, but is the processing facility there? Could we use it in somewhere in the processing facility as wash water? Just to get that one extra step of treatment. And again, these aren't things that are happening right now, but there are things that start to really come into play. And again, as you look on a global scale, instead of just sort of North America, where water is abundant and available, unless of course you're in Vegas. But in general, it's a pretty available resource. But you go to Saudi Arabia and wow, water's a different beast. Or a recent example that came across my desk that I found interesting was a German company that was building a RAS facility in the middle of Germany, which obviously is not near an ocean. So their saltwater retention was a really critical factor. So to them, to throw away salt water was a horrible waste, whereas at a flow-through facility, it's like, let her go. That's not a waste at all, right? And so it changes, I think, from region to region and market to market. And the more we move these facilities closer to the populations, like for example, let's say we had one in Kentucky, and they wanted to do a kingfish kind of concept where you're 30 ppt of salt and you're 30 degrees Celsius, and all of a sudden you're going, well, hold on, where am I going to get salt water in Kentucky? It's a very different ball game as to what is a waste now.
So I think that Laura and Trevor both brought up some great points. However, my mind drifted off into another area, of course. And, when I heard Ben bring up, moving markets, away from their natural, moving products away from their natural area and closer to markets, my mind jumps right to pathogens instantly, and UV, that's what I jump to instantly. Is we in Michigan, we're currently bringing in Arctic grayling from the Alaska, and we have an isolation facility, and one of the things that we're doing there is making sure that our effluent isn't containing any pathogens that may be from somewhere else in the country. But you could also say somewhere else in the world if you're bringing fish in to start a brood stock. And then on top of that, the next thing my mind jumped to is escapees. I understand in RAS that's a little more difficult.
It's a little harder in the RAS. It's tough to escape, but I understand what you're saying. Absolutely.
Yeah, flow through, cage culture, whatever. That could kind of be considered one of our a potential waste product, something that escapes into an environment where it's not native or they don't exist there. So anyway, just a different perspective to throw on top of the good points that Laura and Trevor brought up on those questions.
Well, no, but I think that's the exact purpose of the question, though, is to what is waste, right? Like, you know, it really starts to snowball when you start to think about what really could be part of that thought process, and where can we evolve this to? You know, is it pathogens? Is it viruses? Is it, you know, it's interesting that you bring that conversation up, because I had an interesting conversation with a veterinary association. And they were asking about, well, so if you do concentrate the water and then you discharge it, have you killed off the pathogens and waste? I said, well, if you haven't done a disinfection step, then no. Right. And it doesn't matter whether you reduce the amount of water to 2 millimeters. If you haven't disinfected it, it still has the potential to carry that pathogen through. Right. And so the all of a sudden, the veterinary association is you know, these bells and whistles start going off, and they're like, oh my God, nobody talked about this. So it's really interesting that you bring that up, Aaron, because I think that is an important conversation that we need to have about the impact of bringing these waters and bringing these fish. And the beauty of RAS is we get to control it. Right. We get to have it where the people are, we get to control the process. But the downfall is, you know, well, what happens when we do discharge, or we have, you know, let's say something goes horribly wrong, and you have a fish kill, right? You have a massive mortality process, and all of that water just gets purged, right? And you got to refill or something, you know, God forbid, nobody wants that to happen, but it's a plausibility in the process. And so, you know, what do you do to treat the thousands of gallons of water that are inside that RAS system that is now effectively useless? Nobody wants that problem.
No, absolutely. That's a very interesting point, guys, especially because, you know, if you think about the sort of classic wastes, sending too much out into the environment is going to have unwanted negative consequences, and you know, pathogens then could be very much the same thing, right? You could release water that's contaminated, not even think about it, and suddenly there's a large unintended consequence. So you're absolutely right to say that, Trevor, that maybe the definition snowballs depending on sort of how deeply you want to think about this and how far you want to go down that road, for sure. I'd like to circle back here now as well. Trevor, you touched a little bit on this idea that we could take waste from facilities and find a new use for it, right? And to my mind, that to me is the process of commodification, right? You taking this thing that, you know, there's that age-old adage that, you know, one man's waste is another man's treasure, right? So it's is that approach, does it have a place in the world of hatcheries?
I think it's certainly something that we have to consider. I don't think I could look at anybody comfortably today and say, my God, it's perfect, we've got an answer. And again, I think it really is region to region, market to market, location to location. But it's absolutely one of the biggest questions that we face on a I'll say daily basis is, okay, now what do I do? Right. This is great. I've separated my solid and my liquid. My liquid is good. I'm meeting my discharge permits. What do I do with this? And does somebody want it? And so the quick answer is yes, of course it does, because nobody wants to pay for disposal. And the easiest answer is take it and shove it in a hole in the ground. You know, that's the North American way. Again, I'm from Canada. We like to dig a hole in the ground and stick it in a landfill, and it's wonderful. And it's somebody else's problem 20 years from now. And the reality is we need to think broader than that. We don't have the right answer. And I guess the real question that comes to this is, who should commoditize it? right? Should it be the hatchery or the fish farm or the land-based facility that's commoditizing it? Or should we look to get together as organizations or groups, or, you know, go fund a third party that we all own 2 to 5% of, that's going to take all of our waste and turn it into an actual commodity that is usable and viable? You know, and that is, I think, the ultimate question that gets posed out there is, you know, how do we commoditize it, and who should commoditize it? And I think both questions need to be evaluated, because as much as we're talking about significant amounts of waste, you know, Laura brought up the amount of waste in a facility. You know, these facilities are starting to generate, you know, 7,000, 10,000 kilograms a day. Again, I apologize, kilograms versus pounds. It's 2.2 pounds to a kilogram. Somebody else do the math. But you know, you're talking about not small amounts. You know, you're talking thousands of pounds, thousands of kilograms a day of waste. But does that mean that there's a business model that the hatchery, the fish farmer, want to then take on, right? And that's, you know, one of the questions that you know, one of the ideas that comes to my mind right off the bat is, you know, people are talking biochar a lot, pyrolysis. And my sort of feedback is, I love biochar, I love pyrolysis, I think it's fantastic. However, do you, the fish farmer, the hatchery, want to take on an air emissions permit as well? Right? Like, you've already got a water permit. Do you want an air one? And do you want, you know, you brought up the Aaron, you talked about operator ownership. You know, it's already a struggle to get operator ownership on a solid liquid separation plant and a simple thickening process. Imagine trying now to get operator ownership on like a fully operating pyrolysis system that's making biochar with an air emission guideline. And, you know, you start to go, okay, does this make sense? Or is this something that we could commoditize? And, you know, okay, if we can put this facility near where everybody is and we can bring in the waste stream, could one group go do it for us, right? Then it might make sense, right? And you're also talking, you know, destruction of waste and other value chains. And again, how involved do I want to be in the circular economy as a fish producer or, you know, or hatchery provider? Do I really want to sell lettuce or fertilize? You know, it's that ultimate question. Who am I as a company? Do I want to create the third division or the fourth division?
Right.
And yeah, you can attest to that probably a little better than anybody in the room, Aaron. I mean, that's kind of the truth, right? Like, I'm a farmer, I'm a fish farmer. Damn it, leave me alone.
Right. Yeah. No, I hear you. It's funny because with our waste, we have a couple facilities where, you know, our facility manager, and I've been in that place where I was a facility manager and needed to have a wastewater treatment operator certification, because they're set up like a wastewater treatment. They're going through their, you know, the backwash waters are going into a clarifier and solids are being held in a sludge tank. It's basically a mini wastewater treatment facility. And, you know, how far do we want to go with that? And for us, we're with our waste, who will take it? And a lot of times what happens with our facilities where we do capture the waste is it's land applied under, you know, our there, of course, there's regulatory issues, manure punch pen waste, but it fits into one of those regulations and can be land applied and injected 6 inches underground. So one more point, I want to go back to the mass balance thing. So you know, operator awareness is really key. at one of our facilities, we're very, very cognizant of uneaten fish food and wasted fish food, and we have very good, our it's slipping my mind, but the efficiency of our feed and our fish is very, very good.
I think you're looking for food conversion ratio.
Yes,
Is that the
exactly.
one you're looking for?
Food conversion. I'm talking so much about waste. I'm like forgetting everything else in the.
You forgot the main part of what you do. There you go. That's all right.
So with that, we had somebody come in and analyze our waste, and the value of the waste was low because of how efficient our fish were at pulling the nutrients out of that food. And so they had no interest in our waste. They're like, no, we don't want it. The value is not there for us. They can go to a livestock facility and get waste that has much higher nutrient values. So another interesting spin on commodification of our waste.
So what I'm hearing is do a bad job for your waste to be more valuable.
But then you have to anyway.
I wouldn't recommend that. Please do
not
take that advice. That's really, really bad advice. I think the value of the fish is always going to be higher than the value of the waste.
Yeah,
absolutely.
Well, it sounds then like maybe operators who are interested in exploring that path, it's a very good point that typically in a lot of jurisdictions, it might be outside of the sort of scope of your business, your expertise, et cetera. Maybe a good way forward then is to try and link up with other operators that have similar interests in that way, and then try and approach others in the community that maybe in your local jurisdiction that maybe have more expertise on that.
Yeah, I think that's, thinking through how do these guys, where do they start if they're thinking, how do I commodify this? I think that's exactly right. I think it starts with networking. I think it starts with talking within the industry. What are you doing? How are you doing it? What are the options that are available? Reaching out to the people in the industry like Laura, myself, people that are dealing with it, engineering firms, consultants. And maybe think a little bit outside the box, right? Maybe go to just look around and see who's dealing with waste. Maybe go to a compost facility and say, hey, if I gave you this, what could you do with it, right? And universities, I don't think should be discounted either. The amount of research that's being done, and again, I can speak to the European market right now. The Danish Technical Institute has probably 7 to 10 different valorization projects going on with regards to waste and fish product. I came across a group in the Netherlands who's looking at converting waste products. Now they hadn't considered fish, but we started talking to them about they're making biopolymers and glues off of waste products, and it really starts to get interesting. So again, think outside the box and maybe just reach out to the biology department of your local university, or reach out to the local water department, maybe the civil engineering department. Talk to your local local wastewater treatment plant to see what they're doing in terms of sludge management, because they're doing the exact same things. They're dealing with the exact same problems: solid liquid separation, phosphorus, nitrogen, TSS, even the oil and gas plant around the corner, if there happens to be one, is dealing with the exact same wastewater treatment scenarios that you are as a producer. So see if there's somebody else. Maybe it's not an industry, direct industry individual, but maybe it's somebody in industry, right? That's local, that you can talk to, especially as you get into the closer to the communities kind of concept.
Nailed it. I would to bring that up at some point, but yes, absolutely. Trevor, you nailed it.
Well, guys,
I definitely agree with that, Trevor. And I will say, I think the idea of commodification of agriculture waste is ultimately pretty new, and a lot of like what we're doing, we're stealing from other industries, like we're stealing from the ag waste industry. And so I think, like Trevor said, of like looking at other people who are doing something similar, is I think that's kind of where things are going.
Yeah, I like to call it the newest, oldest business model in the world. You guys have been doing this for decades, but nobody's been doing it like this.
Yep.
Well, it's great points, guys. We have just a few minutes left before we shift into our Q&A section here today. Just real fast, in summary, when you look forward to the future of waste management, what's kind of got you excited? What should people be keeping their eye on? Aaron, if you'd like to take the lead on that.
I absolutely. I don't know. I don't necessarily know what people should be keeping an eye on. But what excites me about the future of waste is sharing knowledge. We have done a lot in the state of Michigan with flow through systems. And at most of the national conferences, we're there sharing our knowledge. So I like to share what we've learned at our facilities over time. And one of our facilities might be considered a gold standard in removing phosphorus for a flow through facility. And we go out and we share that knowledge. And that's what excites me, is sharing this knowledge with other people and getting other people on board and thinking about their waste and what they're doing at their facility. And if one person walks away, we're hitting a home run.
I feel like I have to give a shout out to my old colleagues at the Freshwater Institute. They're doing a lot of interesting research right now in terms of waste to energy. I know they're doing some projects with anaerobic digestion, especially like as it relates to RAS, of trying to, RAS, it's a pretty high energy intensive system. So being able to offset it by using the waste is an interesting idea. And so I think a lot of the technologies, like I said, we're still pretty new in how to handle this waste and how to extract value from it. And I think a lot of the technologies and research going on related to that is what excites me the most about fish poop, right?
From my perspective, I think it really, I appreciate both the responses, and I think they're both bang on. For me, I think it's some of the out of the box thinking that's starting to happen. What can we do with it? Can we turn it to compost? Can we turn it to biochar? Can we turn it to fertilizer? Can we inject it into the ground and use it as a direct deployment? But I think what I find the most interesting is a lot of people that I've talked to are really trying to think through, well, what is special or unique about my area, and what can I do differently? And again, the example that comes to mind isn't necessarily North American, but it was up in Iceland. And one of the attendees at the conference looked at me and says, well, we have cheap power and a lot of heat. Why can't we do it differently? Why do we have to go the old school water liquid separation? And that really started making me go, yeah, good question. Why do we? Is there something in Michigan? I have no idea, but is there something in Michigan that we could use? I don't think you have cheap power or cheap heat. But is there something that we can do? Is there some different technology that somebody's using that we could go look at and go, well, why aren't we doing that? And bring it forward. And again, I don't have an answer, but I like the fact, and that's what does excite me, is that people are thinking that way. They're thinking about, well, what is different, and then to tag on to that, just the, Laura, you talked about the Freshwater Institute. They're doing the compost study, the DTU, the different universities that are looking at this as a potential commoditization. And it's not just, how do I make fertilizer? It's, man, how do I make biopolymers? How do I make glue? How do I make this into cardboard? And again, I don't know anybody making cardboard, but it's people aren't closing their minds anymore. And I do think that's probably the coolest part about the the expansion. I mean, the good part about engineering is there's one book that says this is how you do it. Because you don't need 6 books, because that one book covers it. But it doesn't mean you can't think about it differently. And I think that's probably, to me, the funnest part about what I see every day. And just that it is a global industry, right? Like it's not just Michigan or the States or Canada doing this. It's literally everybody, and they're all thinking about it a different way. Singapore is trying to float a RAS system in the middle of a bay. Norway is trying to blow holes in mountains. Everybody's doing something different, and I love it. It's just unique, right? That's sort of my favorite part.
Well, Aaron, Laura, and Trevor, when you put it that way, I'm pretty excited. Definitely. Now, if we'll move on to some audience questions here, we have two questions today. One from an anonymous attendee. So, how close is the zero discharge concept? And anybody can take the lead on this.
How much do you want to spend? It's there. We can do it.
Bingo.
I can get you to zero. I really can, but I don't think you want to spend the money to do it.
Sure.
The technology exists. It's just, is it worth the money and the capital expenditure for one, and the operating expenditure for two? But you can get to zero. The technology exists.
Very good. Next question from Scott. For conservation hatcheries balancing effluent waste and economics, what is the recommended best method for waste management, or a starting point for these types of facilities? So I think what he's getting at here is more in the sort of startup space. How do you balance these more stringent requirements with potentially limited financial resources? What's a good place to start?
Run screaming? Sorry, no, that wasn't. Go hire a really good fundraiser. No, I think my perspective would be start with the simple solutions, which is just use gravity to your effect. Get a good understanding of water treatment. Aaron, you talked about pH. How can you use some pretty simple pH neutralizers and processes to affect the quality of the water? Are there simple things that you could look at adding to precipitate faster? Are there retention methods that you could utilize that are pretty straightforward? Just, just keep it simple, I think is the reality. And just remember, things either float or sink, typically. Use that to your advantage, and then maybe use both of those things to your advantage, in that mindset. I mean, those would be my initial thoughts. Laura, you strike me as having more experience with the conservation hatcheries than I do.
I think there's some pretty tried and true methods out there to treat waste, and the first step is always getting the solids out of the water, right? Like Trevor said, is getting as many of the solids as you can out of the water, really cleans up the water pretty quickly. And I think in terms of balancing like the economics and kind of more stringent regulations, it's always good to build and design for what the regulations are today, but have the flexibility to expand and to be able to, things are not going to become more relaxed, right? We're only going to see more and more stringent regulations. So build systems that have that flexibility.
Now, the next question from Lori, has anyone, they're asking about capturing heat and thermal load as a source of waste, and sort of recapturing that, reusing that. So just in a quick nutshell, what's a good place they should be looking for information on those kinds of systems?
I guess it depends on where you want to deploy that heat. Heat as a resource is only valuable if you have somewhere to use it. That's the biggest thing. Typical concepts, heat exchangers, simple heat exchangers, shell and tube, single pass. Think the outdoor hot tub with wood burning around a copper coil kind of concept. There's lots of ways to recover heat in a relatively inexpensive fashion. I mean, there's everything from that to a heat pump, right? Where you can use that heat. We use recovered heat at one of our facilities on our dryer to dry the sludge to greater than 90% dry matter. So there are ways to reuse that heat in different fashions. So it's kind of a complicated question. But again, it really starts with, what do you want to do with that heat? You want to just heat the office? Well, that's one thing.
Perfect.
I guess the question is it how to, like, because I've seen hatcheries where they are discharging too warm of water, and so
that's a different thing. That's a very different question.
If that's kind of the question, it's kind of a little bit of a different answer. It's ultimately water. It's hard to either heat or cool water, and so if you can get the total water stream down, that can be a big advantage of trying to reduce thermal heat. Right? If there's less water going out, it's easier to either manage the temperature of it, or it'll have a less impact on the body of water that is being discharged to. So that'd be the only thing I would add in case the question was a little bit different.
Just in case I completely misinterpreted the question. I appreciate that. No, that's a valid approach. I like that.
Just our last question today here, and it's a two-part question. I think part two, I'll try and connect Aaron maybe with this person so you can answer directly. But real fast, they're asking if there's any tools. This is Bill asking, any tools or sensors for measuring phosphorus in real time?
Not that I'm aware of.
No,
we have
define real time.
I suppose in a flow through system, all the water flowing out of the system, can you're like an oxygen sensor in your tank. It's going to, be testing constantly and feeding that information to you all the time. Do you have something like that for phosphorus, or has anybody come across anything like that?
I don't think you can measure total phosphorus in terms of real time, just because, right, phosphorus kind of appears in water as two different forms. It forms attached to like the solids of the total suspended solids, and then there's also the dissolved phosphorus, which is a lot harder to get rid of. And so I think in terms of measuring total phosphorus, which is typically what is monitored from discharge, you kind of have to look at both of those in the water column, or like in the water sample. And I don't know if there's any real time for measuring dissolved phosphorus. I'm not familiar with anything like that.
Very good, guys. Well, we're out of time today. I really want to take this time to say thank you very much, Laura, Trevor, and Aaron. It's been a great discussion. We really appreciate your time today. Thanks again. At this time, I would invite you to turn your video off, and we'll continue our discussion with the audience here. So, folks, as I mentioned, that's all the time we have today for this webinar. Thanks again to our panelists for donating their time to this important topic. And thank you, the viewers, for submitting your questions and participating in this broadcast. Once again, I'd like to mention our sponsor and say thank you very much to Oxyguard International. Before we leave as well, I'd like to remind you folks to sign up for the 2024 Hatchery 101 webinar series. For those of you who sign up, we'll see you on Valentine's Day. Take care.